started at Stanford in 1981. So I'm pretty old, but I think that's relevant because if you think about computing in my lifetime, it has changed considerably. Now, in high school, they started introducing some of these personal computers. There was an Atari, there was a Game Station, a Commodore 64, Apple II. These are all very basic machines. And in college, I graduated up to much more powerful computers, but it was really just a console that you typed on. And the computer was actually in another room, right? And I learned a couple of nice languages there, Pascal and assembly language. And then when I went to Intel, well, I first started as a product engineering, and the machine here that you see underneath those computers is actually one of our pieces of test equipment. And that required huge amounts of programming. It's not what I was designed to do. I'm actually an electrical engineer. But wow, I had to do Pascal and C, and we ended up actually rewriting the entire operating system for that device. And some of the other things we had to do is we had to learn how to use Excel and databases and things like that. And then as a design architect, we did assembly, which is the kind of the native language of the computer. We did Verilog, which is actually how you design the computer chip. And then we did even lower level code like microcode and P code. And the interesting thing is, all of my industry work was done in teams. It was never done by myself. So a lot of times we're used to, at the level you're at, coding by yourself and owning a whole project. And it's really interesting to learn that that's not the way most things work, right? Most things work based upon working in teams. So my advice to you, I believe computing applications are only going to grow, right? This is an area of growth. Think just about what computer science has done during this pandemic. How many of you are using Zoom on a regular basis, right? But that's all being driven by computer scientists. The web applications that have been developed for contact tracing so that we could go maybe to Hawaii or other places and we could find out how it's being spread. The apps that supported contactless interaction, whether it be ordering things online or whether it be paying for things without touching things, all that came up in a span of how many months, right? Think about the vaccine. Why did it come so fast? Well, maybe 20 years ago, we actually sequenced the human DNA genome, again, based upon computing. And now we're able to do it relatively quickly for these types of viruses. And that led to approaches that led to the vaccine. So again, even though it's a biology thing, computer science is involved. So I believe strongly that the ability to program at some level is going to be a necessary life skill. It's going to be something that you're already seeing taught, but it's going to be something that's going to be a requirement like math, unfortunately. But every discipline is going to require some level of programming, including those you might not expect. I mean, not a lot of people think of biology and they think about, hey, I'm going to need to program. You are, right? And I think it's actually going to make a difference in terms of your ability to be employable for higher paying jobs, right? And the other thing is, I think it gives you, once you learn one language, it's really not terribly difficult to pick up other languages. It means it makes you more flexible. So I think that, again, as things continue to grow, you're going to, in the CS world, if that's the area you go into, you're going to have you're always going to be able to find something that you could do, whether it's something you create, your own app, or something in support of everybody else. So how do you prepare? Well, obviously, math and science classes are really important. But I would tell you to focus on the concepts and the connection of how things work versus actual memorization. As a math teacher, I see a lot of people focus on just, oh, I got to memorize this formula. And it's like, no, you really need to think about why the formula works. Because a lot of what you're going to be doing in computing is applying that same sort of logic. Take classes that are available in STEAM or in programming at your school. Really do not be afraid to explore on your own, right? Do you have that idea for a great new game or an app on your phone? Try to make it. even if it's one that already exists, right? Even if it's something that's already in place. Don't be afraid to try to write the hardware. And finally, participate in hackathons if they're available to you. Get involved. Maybe even organize one at your school.